Hi everyone, thanks for coming out to hear this lightning talk. My name's Rob Neely, the Radius project lead. I'll give you a very high level overview of Radius and encourage you to stick around and check out some of the additional booth materials if you haven't already to learn a lot more. So at a high level, what are we about? Well, we want to accelerate HPC application development through a robust and well-supported software stack, largely developed here at Livermore, all of it open source and easily downloadable and buildable. And since I get asked all the time, RADIUS is an acronym. It stands for Rapid Application Development Using an Institutional Universal Software Stack. So how do we do that? Well, there's really three main thrusts in this project. First, we do provide direct support to software developers who are developing parts of this software stack. This is all open source software, and we want it to be robust. We want it to be well documented, well tested, have things like tutorials developed where that makes sense, and for you to be able to do some outreach to get your software more broadly adopted and ideally contributions back into it. We want to have mission impact at the lab, and that's best served through integrating the software into Livermore applications. And we firmly believe that applications should be adopting more third-party software so that they don't have to maintain their own solutions. They can rely on this software inside Radius that is well tested, hardened, ported to a number of machines, and they can then focus on their core mission that their application was meant to address. And finally, HPC development is hard, and so we're trying to do some of the same sorts of things that the rest of the community is doing in DevOps, and try to determine what does that mean in the HPC space to do things like continuous integration in HPC and automated builds and deployment. And so we're using the Radius project as a way to really define what HPC DevOps means going forward. So diving one level deeper, when we talk about the Radius software stack, we're talking about products that fall into the categories across the top here. There's a slide deck available at our booth that will show you all the different products under these categories. So I encourage you to take a look at that. And then again, build on some foundational concepts around this idea of DevOps that I just mentioned. In addition, we really want to encourage people to adopt common ways to do development and policies to encourage that and tooling to make it easier. We want training and documentation to be ubiquitous. We want to leverage programmatic investments. Again, the software is supported primarily by the major programs at the laboratory, and Radius is just providing that additional bit to help with supporting a broader open source community base. And then, as I mentioned, integrating these into Livermore applications. And really, Radius was created out of the idea that software is now core infrastructure at the laboratory. You just need it to do your job if you're an HPC developer. And just like lab space is important to biologists, reusable software components are critical to application developers. And we should maintain that as a core capability here at the laboratory. So we think we've got something for just about everyone at all parts of the HPC software development cycle. So this is just a sample menu of some of the things that we offer. If you want to improve your builds, you should take a look at a tool called BLT. It integrates nicely with CMake to make your builds more robust. SPAC is a package manager for HPC developed here at the lab that's really caught fire worldwide, and can help you manage the dependencies that we're asking you to adopt in the form of third-party libraries. Caliper can help you instrument your code for performance, and then Spot can help you make that ubiquitous by tracking your performance over time. If you want to deploy on GPUs, the Raja suite of tools can give you a performance portable solution for C++ codes. You want to improve your testing, GitLab CI. We don't develop, but we're developing some of the infrastructure to make it easy to use in Livermore computing for codes either hosted on GitHub or inside the lab repos. Um, Ascent, if you're interested in looking at in situ visualization and analysis, we do that through a tool called Ascent and an interface called Conduit that's very general purpose. And if you're writing a lot of files to disk to do visualization, you're probably going to want to think about something like in situ visualization going forward, and this makes it really quite easy to adopt. And finally, workflows are the way of the future in HPC development, things like ensemble analysis and integrating with AI workflows. So tools like Maestro and Merlin we have under our umbrella here. And so the project here is really about promoting adoption, assisting you with integration, supporting and maintaining these things for the long term, backed by programmatic investment. That really, in a nutshell, is what Radius is about again. So I mentioned continuous integration. In the first couple of years of Radius, we partnered with Livermore Computing to establish GitLab as the tool of choice going forward. There's a poster here at our booth by Adrian that I'll encourage you to take a look at to learn a lot more about that. But I quickly want to just talk about what we're going to expand that to do next year is, again, partnering with Livermore Computing. We want GitHub teams to be able to test contributions from external developers on LC hardware in the continuous integration mode before going through and accepting it and blessing it. Right now, any software that runs on Livermore Computing has to be approved and accepted by a Livermore employee, making continuous integration difficult with external contributions. So the plan here is to put some mirrored hardware outside the lab firewall and have some GitLab runners that will monitor pull requests on GitHub and do the testing there. And if it doesn't pass, make a notice back to the developer for them to make sure that their contributions work in our environment before we go through accepting them into the main line of our code. And because we're using SPAC as the initial test case here, SPAC itself builds 4,000 plus products, so all of those will end up being tested regularly on Livermore Computing style hardware. So I mentioned how application impact is a really important piece of this project, so wanted to give you a couple examples here. Starting with ELAC, this is developed over in global security to model acoustic wave propagation in the solid earth and atmosphere. And they recognized that their sponsors were demanding higher resolution, larger problems, and that GPUs were the natural next step for them. Fortunately, we had some success with a seismic code called SW4 that had a very similar code base. That code you may have read about some of the earthquake simulations in Science and Technology Review or News Online. But it was ported to GPUs with great success. And because ELAC had some similar underlying algorithms and code structure, we thought we'd sort of mirror what they had done with SW4 in a project called the Institutional Center of Excellence to try to get some similar wins. And so with Radius, we partnered with that application team to improve their testing so we could make sure that changes we made along the way weren't breaking things. We converted some Fortran code to C++ so that we could adopt a performance portable solution in the form of Raja. We've been verifying correctness along the way and currently are in the midst of seeing ever improved gains with targets that we're hoping to see 10 to 15 times faster node for node performance versus some of the CPU systems on systems like Lassen. Bout++ is another application we've been working with for a while. This is a popular code in the Fusion Energy Science program. It's models the key physics in tokamaks and stellarators, and it's used in a number of SIDAC projects and is really a globally developed and used code with a lot of the development centered here in Livermore. They also recognize the need for GPU acceleration, and so with Radius, we helped solidify their build system to make it easier to port to non-CPU systems like Lassen and the NERSC systems that are being stood up. We added Raja and Umpire and did that in a way that minimized the impact on the developers and what they need to know to write GPU code. And we adopted a GPU-friendly version of Hyper to replace their existing solver that solved their Poisson's equation. And again, early results, are already demonstrating great speed ups, and we think you're going to be able to do some really groundbreaking science as a result of this work. So, why should you stick around and learn a bit more about Radius? If you're an application team, we want to get you up and running with some of this software. So check it out. And if there's something that piques your interest, we can work with you to get that integrated into your application. If you're a software developer, maybe on one of the existing products under this banner or one that you would like to get included under the Radius banner, we've got some funding we can provide you to do things like bolster your documentation, improve your testing, and basically get the word out about your product to other users at the lab and beyond. There's a couple websites here at the bottom where you can learn a little bit more information. You can email this radius request at lnl.gov for more info. That'll reach one of our team leads. And there's a listserv. You can go to the listserv.lnl.gov and join Radius-Announce to hear about things like upcoming tutorials that these products may be offering. So with that, I'm happy to take any questions, and thank you very much for your time.